Oh, I was not sure that I was not even aware that my volume is a bit down. So it means to say, maybe now you can hear me. I was not sure if I'm audible or now or not. Okay, now we're gonna be dealing with exponential functions. Ne? So for you to be able to master exponential functions, at least you must have a background information of what we speak. Ha re bolela ka exponential functions. So one thing that you basically need to understand is that in maths, whenever they speak about functions, you're gonna come across different types of functions. Of which functions, normally we are speaking about graphs, ne? Of which you must know linear functions, which is a straight line graph, of which you must know quadratic functions, which is a parabola, as well as you must know exponential functions, which is the one that I'm gonna teach now, as well as you knowing hyperbolic functions. Ne? So those are things which, or those are types of graphs that basically you need to understand with regards to that. So the basic equation of an exponential function, we welcome you, Lani. So the basic equation of an exponential function is given as y. It's equals to a ab to the power of x, ab to the power of x. So an exponential function is a function in the form y is equals to ab to the power of x. Or if it's not written as y is equals to ab to the power of x, it's going to be what? F of x, it's going to be equals to ab to the exponent of x. So why am I writing it like this? I want to show you to say y as well as f of x is one and the same thing. So that's how basically we write that. And then in this, there are parameters which you need to actually take into consideration with regards to graphs. Parameters. So when I'm speaking about parameters, this is what basically we are having with regards to the effects of the graph. So we know that b is a positive real number. So one of the parameters that you must know is that b in this equation right here, y is equals to ab to the power of x, we know that b is a positive real number. So always gonna be is a positive real number. So that's one thing that you need to know. Positive real number. So you must know that. Before you can even go further, you must know that. So it's a positive real number. So these are parameters of the graph. Each and every graph, whether it's a straight line graph, parabola, or exponential function, or hyperbolic function, that we are having what we call parameters. So we know that on this, y is equals to a to the power, y is equals to a times b to the power of x, or f of x equals to a b to the power of x. We know that b is a positive real number. Ne? And then other than one, positive real number, other than one, other than one. So you must know this. So we say when we say positive real number other than one, there's no way the value of b can be one. Ne? And x can be represented by any real number. And then another parameter is that x, it will be represented by any real number. By any real number. X will be represented by any real number, just like that. Ne? So that's one thing that you need to understand. And then, since this is an exponential function, always, an exponential function always, ne, always has one asymptote. Always has one asymptote. One asymptote. So always, this is gonna always have one asymptote. So why am I saying it's always going to have one asymptote? So guys, never confuse the two. So you'll always come across what we call an asymptote as well as an axis of symmetry. An asymptote is a line that does not touch the graph. Asymptote, any line that does not touch the graph, does or never touch the graph. Never touch the graph. Never touch the graph. Or never touch the graph, just like that. So an asymptote, normally we show it using dotted lines. And then one thing that you need to understand, let me just write that. Asymptote is always shown using dotted lines. I'm going to show you what is an asymptote. Asymptotes is always shown using a dotted lines. It's always shown using dotted lines. Using dotted lines. Sorry for my handwriting. Using dotted lines. So what do I mean by this? Now let me show you an example. I'm just gonna draw a, a rough sketch of a graph, but I'm gonna show you the good procedure in which it's gonna help you into knowing how do you draw an exponential function. So now I just wanna show you an example of an asymptote. Example of an asymptote. So in this instance, let's say you are having a Cartesian plane like this, ne? And then here we are having that being -1. We're having that being -1. So since this is -1, I'm saying, let's say this one is our asymptote. So remember here on this statement, I've just said asymptote is always shown using dotted lines. So let's say here on -1, we're having an asymptote. So that's because of it's shown using dotted lines, we just draw it like that. But I'm just going to show you the proper procedure in which you should know with regards to drawing the graph and how should you draw your graph. Then let's say our graph, it moves like that. So we'll define that, we'll define these dotted lines to say this is an asymptote. You know why I'm saying it's an asymptote? It's because of it's shown using dotted lines. Not only that. And then it's not always going to be the case that it's at -1. The reason why I'm saying it's at -1, it's as, for an example, uh, having it, maybe let's say this equation was like y. Maybe let's say, yeah, let me write it properly. Let's say the equation of this line, it was y, it's equals to what? 2 to the exponent of x, and then 2 to the exponent of x, and then -1. So just because of from this formula, why we are having y is equals to 2 to the exponent of x -1 or -1, it basically means to say this -1, it represents what we call the asymptote. So it represents the asymptote. Represents the asymptote. Represents what we call the asymptote. It represents what we call the asymptotes. So a lot of learners, they confuse an axis of symmetry as well as an asymptote. Also, an axis of symmetry, it is having dotted lines, but it's totally different from an asymptote. You know why? An axis of symmetry is the line that divides or cuts the graph into two equal parts. So any line that cuts or divides the graph into two equal parts, we call it an axis of symmetry. But in asymptote, it's also shown using dotted lines. This is a graph. That's why I'm just said this is a graph that will never meet the graph, or it does not touch the graph here. Me saying this statement right here, I wrote it for a reason. This statement never touched the graph. You see this one, using dotted lines is an asymptote. So as we are drawing our green graph right there, just because of it does not touch the yellow dotted lines, it means to say that dotted line it acts as an asymptote. And then for you to be able to remember how do you see an asymptote, you just take it from the formula. So if this formula here it's -1, before you draw your graph, you must go at -1 and then you make it dotted lines that represents the asymptote. And then in an instance whereby maybe it was +1, it basically means to say my asymptote was gonna be somewhere here at +1. So those are things which you need to actually know. Any question? And then they're gonna also ask you about domain and range because we're dealing with functions, but it's a topic for another day. Now I just wanna teach you how do you draw the graph. Let's say they want us to draw the graph. It's an example. Now I'm showing you how to draw the graph. So to be able to draw the graph, there are two ways or two methods in which you can be able to draw the graph. Number one, we're gonna use the famous one or the one that is mostly used, which we call it the table of values method. Or the other one, you can use the intercept method, whereby you are saying x-intercept, let y equals to 0. Y-intercept, let x equals to 0. But the reason why I want to introduce, okay, this one, let me write the question. So they're saying draw the graph. Draw the graph of y equals to 2 to the exponent of x. Of y, it's equals to 2 to the exponent of x. So that is our graph that we're going to draw, right? And then in that instance, I'm going to say for what? For x is equals to -3, or I'm gonna draw my table of values like this. So you must make sure that your table of values is small as well as what? It's small and straight to the point, because if you're gonna draw this is x, this is y. If you're gonna draw a table of values that has many blocks, you'll end up your graph having many. You'll end up having your graph being a big graph on an A4 page. So just use smart method to say, okay, let's start at -3, then followed by -2, followed by -1, followed by 0. After it is followed by 0, followed by 1, followed by what? By 2. So we can end up at 3, just to make the graph to be neat as it is. So what basically you can do, remember here is just that I didn't write it. But no, now you know what, okay, here we're going to have the equation of the graph that is best defined as y is equals to 2 to the exponent of x. And then for you to get the respective answers here, what basically you're going to do, you're going to go on a rough sketch, then you write the equation of the graph, y is equals to 2 to the exponent of x. Let me write it properly, 2 to the exponent of x. Then after writing y is equals to 2 to the exponent of x, you're going to come here and say 4 x it's equals to -3. So when you're saying for x is equals to -3, this is x equals to -3. We are starting here. So we want to get our answer there. So what are we going to get? So when we're saying for x equals to -3, guys, it basically means to say you come back and rewrite the equation as it is right here, which is going to be y. It's equals to 2 to the exponent of x. And then after that, in the place of x, you put -3. So that will be y. It's equals to 2 to the exponent of -3. And then what is y is equals to 2 to the exponent of -3? You can press your calculator, or if you're familiar with your laws of exponents, you know that this is y. It's equals to 2 to the exponent of -3 is the same as 1 over 2 to the exponent of 3. Then at the end of the day, this will actually give you 1 over 8, because uh 2 to the exponent of 3, it gives you 8, just like that. So it basically means to say where x is equals to -3, our y is going to be 1 over 8. So here I'm just going to write 1 over 8. As easy as that. And then you follow the very same procedure or the very same method to say, okay, since you now got that one, you're gonna say y again, it's equals to 2 to the exponent of x. And then after that, you're gonna say 4 x is equals to, now we're gonna say for x is equals to -2 because we want to get this value right here, right? And then when you're saying for x is equals to -2, it basically means to say you go back here, you rewrite the equation as it is to make your work to be much neat. Then that will be y, it's equals to 2 to the exponent of x. And then after this, it means to say in the place of x, now you're going to substitute by -2. So you're going to have 2. But just because of the value of x right here is given by -2, we're going to say to the exponent of -2. This one, without even wasting of time, 2 to the exponent of -2 is the same as 1 over 2 squared, which will give us 1 over 4. If you don't know this, you can just punch your answer to the calculator, you'll get the respective value. So here we're going to get 1 over 4. You do the same with respect to all these values. You do the same with respect to -1, 0, 1, 2, 3. By just saying, utilizing this concept as well as utilizing this concept, and then whereby x is -1, you're going to put there to get an answer. Whereby x is equals to 0, you're going to put there to get an answer up until you reach to 3. And then you doing that, the answers that you're going to get, these are the following answers. For x is equals to -1, you're going to get 1 over 2. So here you'll get 1 over 2. You use it, this concept that I was teaching you. For x is equals to 0, you're going to get 1. So that will be 1. For x equals to 1, that will be 2. For x is equals to 2, that will be 4. Lastly, for x is equals to 3, that will be 8. So all these answers, I'm not guessing them. I'm just trying to show you how basically we got that with regards to me showing you this concept as well as that method to get to see. And then another thing that is very important that you must always remember before drawing your graph. Let's come back to our equation. Remember, our equation is y is equals to 2 to the exponent of x. To start with, do you know that this equation y is equals to 2 to the exponent of x is one and the same thing with me writing y it's equals to 2 to the exponent of x plus 0. You know why? 0 doesn't have any effect. And then if you go back to the basics that I've taught you with regards to exponential functions, I said this value right here. Yeah, I even made an example to say, let us draw this graph. You see this value right here. Even if they don't tell you, you must know by heart to say, this -1 right here, it represents the asymptote. And then I told you to say the asymptote is shown using dotted lines. And then just because of this is -1, you're going to go at -1 and then you start by writing your asymptote. You're going to do the same. There's a reason why here I'm showing it. I'm showing all of you like this, because if I'm not going to show you like this to say y is equals to 2 to the exponent of x is the same as y is equals to 2 to the exponent of x plus 0. 0 doesn't have any effect. At the end of the day, it's going to disappear. Then it gives you this, of which that is what I was basically trying to say. It means to say, now since you understand Uguti, y is equals to 2 to the exponent of x is the same as y is equals to 2 to the exponent of x plus 0. You will now ask yourself a question, Uguti, what does this 0 represent? It means to say this 0 represents what we call what? The asymptote that I was telling you about. And then since now you understand Uguti, it represents the asymptote at 0. It basically means to say when you are going to draw your graph should never touch the x-axis, because y is equals to 0 at only the x-axis. It basically means to say you're gonna draw your graph neatly like this. You're gonna draw your graph neatly like this. Let me teach you maths. You're gonna draw your graph neatly like that, and then this one we know good. Okay, that will act as our x-axis. If you can draw your graph to be neat, then you'll go very far. These things are not difficult. So you label it neatly to say, okay, this is the x-axis to tell them that you know your story. And then with regards to the y-axis, you play around these numbers. 1 over 80. So what you can basically do, you can just say that is 1, because the highest number here is 8. So 2. So we're going to say that is 1, 2, 3, 4, 5, 6, 7, as well as 8. So you just say 1, 2, 3, 4, 5, 6, 7, as well as lastly 8, somewhere there up. And then one thing that you need to understand, okay, we're having -1, -2, -3, -4. So -1, 2, 3, 4. And then here we're having 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then after that, guys, you now plot your graph. To start with, remember I told you, Guti, this x or this 0 to say, it represents the asymptote. It means to say, that's why now you have an understanding of how I've drawn my graph. To say, okay, y is equals to 0 only at the x-axis. Hence, this graph is not going to touch the x-axis. Because at the same time, that x-axis, it acts as an asymptote. So now let's plot it. We know we must plot our what? Our -3 goes with 1 over 8. So it's going to be -3 as well as 1 over 8. -3 is 1, so let's 1 over 8. It's going to be somewhere slightly right there. But it doesn't touch the x-axis. And then -2, it goes hand in hand with 1 over 4. It's going to be slightly somewhere there. And then -1 as well as half, yeah, in between. You must draw your graph neatly with equal graduations. And then 0 and 1, you see? See that? So look at how my graph is going to be moving. Okay. 1 is going to go hand in hand with 2. So where 1 and 2, they meet to make a dot again. And then 2 is going to go hand in hand with 4. So where 2 and 4, they meet, we're going to make a dot again, somewhere right there. So now we are drawing an exponential functions. Lastly, where 3 and 8, they are meeting, I'm going to make another dot. So as to show the person who's going to mark my script to say, you know what, Sir has taught me. Sir has taught me how to master the art. Take in consideration that you go back to those. I've told you to say, okay, there's a reason how I teach you like this. Because if I'm not going to show you to say this 0 is x as an asymptote, someone will draw the graph and then it touches the x-axis, hence you're going to be wrong. Because an asymptote is a line that will never meet the graph, or is a line that will never touch the graph. So it basically means to say, as that is coming from -infinity, it moves like that, like that. So one thing that is very important and profound is that all your coordinates should be in alignment with regards to you drawing your graph. We are having a dot right there, another one right here, another one, another one, another one. And then you end up labeling your graph to say, you know what, say, this is my graph, y is equals to 2 to the exponent of x. You drawing it like this, me as an examiner or a marker, I will be able to see what to know. You know what, this person actually knows his story. So look at this graph that I've just drawn right here. This one, as well as this one. Can you see the difference between the yellow graph and the green graph? So the green graph is just that on the green graph, you're having an asymptote at -1. That's why this graph, that asymptote is below the x-axis. And get this is y. And get that is x. But when you look at this one, because you know that here there is +0, it means that that +0 is coming from us having the y being 0 only at the x-axis. Hence, that graph you should never touch the x-axis. Any question? Any question?
So say
No, sir.
Okay. Yeah.
when
You.
using, I have a question. When using this method, are we allowed to use any number range?
Yeah. You are allowed to use any number each. So yeah, it's a good question. So you are not only restricted to starting at -3, ending up at 3. The only difference is that to someone will start at -5, ending up at 5. The only difference is that to that particular person, again, we're gonna start at -5. It basically means to say, let me use a different color. The one who started -5 as well as 5, he will have another coordinate right there. He will have another coordinate right there. He will have another coordinate somewhere up there. He will have another coordinate up there, and then you end up joining your graph. So that's the only difference. Am I making sense?
Yes, sir.
Yes. But you must make sure that you must play around these numbers. Don't make your numbers from -10 to 10 because it will be an instance whereby your graph it fits on the whole book. So you must be smart with regards to that. It's a good question. Yes. Yolani, you also have a question.
No, sir.
Oh, do you understand, Yolani?
Yes, I understand so far.
Okay. And then it's Yolani, and I forgot your name. You know, I'm forgetting your name. I'm forgetting
My
your
name
name.
is Lisa Olivesi.
Yeah, Little Nolo. Little Nolo. Oh, it's because your name is too long, so I'm gonna say Nolo. Nolo. Yeah, I'm gonna say Nolo for me not to forget. Nolo, do you
No
understand?
problem, sir.
Okay.
Yes, I do.
Yes. So do you see with these graphs? They're not difficult, guys. They just need you to know AMA basics. I want. So okay, since there's no question with regards to that, uh, yeah. So let's say let me uh let's say on this question, after drawing the graph, they want you to 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 find the domain and the range. Ne? So these ones, a lot of students they like running away from the domain and the range. A lot of learners, when we are teaching, they hate this question. Domain and the range. Ah, they don't like it, honestly speaking. But let me teach you because it's part of the question. Domain. So they're gonna ask you about domain and range. And you know why I'm introducing this concept of a domain and range? When they ask you about domain and range, it has to do with you interpreting the graph because there's no way they can ask you the domain and the range without them drawing a graph for you or without them telling you to draw the graph. It's either you're gonna find the graph being drawn, then they want you to interpret to say, okay, determine the coordinates of A, find the domain and the range, or they will say draw the graph, find the domain and range. So one thing that you need to understand when you speak about domain in maths is all possible values of x. So how about what is a domain? You must tell them to say, Seth told me to say, domain is all possible, is cool. All possible values of x. And then the values of x. And then when we speak about the range is all possible values of y, guys. Range, all possible values of y. All possible, sorry for my handwriting, all possible. Let me try to fix it. All possible values of y. All values of y. So that's why you find Luguti when they're asking you what is a domain. And since it's all possible values of x, we end up saying, okay, let me do like this. We end up saying x is an element of real numbers. That's why normally from lower grades, grade 8, grade 7, grade 6, we told you what is real numbers. So when we're saying x is an element of real numbers, it's because of domain. Domain is all possible values of x. So we are saying x is an element of real numbers. Real numbers is all negative as well as positive values. So when you speak about real numbers, it's all negative and positive values. You know why I'm saying all possible values of x or domain is x an element of real numbers? It's because of they want you to check the graph that you have drawn. Does it include negative values as well as positive values? Yes. How do I see that? Let me show you. So this graph is coming from negative infinity. It includes all the negative values. And then here, it includes 0, English. And then up there, it includes all the possible values of x. That's why here, I'm ending up by just saying x an element of real numbers because real numbers is all negative as well as positive values. Not only that, someone can also write it like this. It depends on who's teaching you maths. You can write it like that. I can decide to say for my students, let's write our domain to say x an element of small bracket negative infinity up until positive infinity. You're 100% also correct. You know why? Because a domain or a range, you can write it using an interval method or an inequality form. An interval form or an inequality form. Do you get to see that? But one thing that is very important and profound that you should never miss is that whenever you are writing the domain to say x an element of, since this graph, we don't know what is coming from negative what. That's why I'm saying it comes back to the question of 𝗘𝘅𝗽𝗀𝗀𝗀 to say at what range should you use that value? Someone can use negative 100 to 100, but it will be an instance whereby you are having many values. Whereby if you were to draw your graph, maybe your graph, it will be you drawing it from Pretoria going to Joburg because you're starting from negative 100 up until 100. It comprises of a lot of coordinates. Hence, you'll be drawing your graph from Pretoria going up until Joburg. You end up having a big graph. Do you get to see that? So, but just because of we don't know what this graph, where is it coming from? It's coming from negative infinity. So I'm gonna write negative infinity here. Taking into consideration to say, taking into consideration to say, if I'm gonna write negative infinity, I don't know where the graph is coming from. Hence, I'm gonna use a small bracket. Guys, let me teach you maths. Ne? In 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 what? In maths, when they say you don't know where your graph is coming from, you use small bracket. If you don't know where your graph is ending at, use small bracket. So just because of I don't know where this graph is coming from, just because of I don't know where it's ending, I'm gonna use a small bracket on either both sides. And then an instance where you use the brace or a big bracket, which is like this, that's where you know this graph starts here or it ends up here. Am I making sense, Iltonol? Sorry about that.
Yes, sir.
Okay. Yeah. And then with regards to the range, you'll say y is an element of real numbers. But not only that, real numbers, again, you know what it's negative values and positive values. But you know what here, even if they didn't tell me, but I've just explained to say, okay, this x-axis where I'm highlighting, we know what we're gonna have our asymptote. That's one thing that I've explained. And then just because of this is y is an element of real numbers. Real numbers is all negative as well as positive. But this graph, it doesn't touch at zero. It doesn't neither have any negative value because that's why you don't have the graph underneath here. It means to say, you will say y is an element of real numbers, not only that. And then you continue to say comma, where y is greater than zero. Don't say greater or equals to. Let me teach you. If you're going to say greater or equals to, you're going to be wrong because you're not saying greater than, we know good, it's anything above. Equals to, you are saying here exactly at the what? At the x-axis, hence you are wrong. Because here at the x-axis, that's where you are having what? Your asymptote. Hence your graph should never touch that. That's what I'm saying. When you're going to write y is greater or equals to here, you're going to be wrong. But rather you write y is an element of real numbers, comma, where y is what? Where y is greater than zero. Because we're not saying greater than zero. It doesn't necessarily say we are starting at 1. It's necessary mean to say from 0, 0,1, 0, 0,2, 0, 0,3 up until going to positive infinity. You are correct. Or you're going to write it like this. You're going to write it like this. You'll say, okay, my range is what? It's y is an element of, just because of you have an understanding with this graph, at least it must start somewhere there at 0. You'll say brace, and then you say 0, comma, just because of you don't know where the graph is ending, going to the upside on the y-axis, you're gonna say positive infinity. But just because of I've told you, Guti, if you don't know where the graph is ending, what do you put on the other side? Am I gonna put a brace or a small bracket later on?
A small bracket, sir.
100% small bracket. Oh, then you get your distinction. It's very easy. Is it difficult?
Not really.
Not really. Do you see? So that's how basically we will write our domain and range. I welcome you again, Yolani. I think you had a problem of a network challenge there. So yeah, but the good part is that I've recorded the session and then I'm just gonna try to upload it so that if you missed some concept like Litonolo now, where I was explaining the what the range here, she didn't even understand me because of that network problem. And then we are left with some few seconds. It basically means to say, as I'm gonna upload it, you'll be able to recap what basically I did. But guys, whenever you come with functions, you must know how to draw them just because of how I've showed you. Then they're gonna ask you domain in the range. Math is not difficult. I'm here for you guys up until we write metric. So I'm gonna teach you throughout, then you'll understand how I teach. So make sure that you, whenever I teach, you make notes, you ask where possible, and you practice, practice, all right, and practice. Then the rest will be history. Any question?
We don't have any questions, but I have a request.
Yes.
How about you give us a question to test our knowledge on what you were teaching us?
Okay, it's a good question. I'm gonna send you now on the group based on what I was teaching you now. Yo. Okay. I was basically saying, and I'm gonna send you the homework now on the group.